This video shows the construction of a small building designed for use as a home office or garden recreation room. The same system is used for bungalows, houses, or flats, but the physical specifications of the foundation and steel subframe would be adjusted to suit the site ground conditions and the size of the building. Holes for the concrete post foundations are drilled individually, so there is no need to lay a concrete slab. Fixing rods are set in quick-drying concrete that is used to fill the drilled holes and form a level base for the metal subframe. Where necessary, steel reinforcing is added. The steel subframe is fixed to the threaded fixing rods. This frame keeps the building off the ground to protect it from damp or even flooding. And should the need arise, the height of the frame can be increased in increments of 200 millimeters, even years after construction. The prefabricated insulated floor panels are now laid on the metal subframe, screwed securely to each other and to the metal frame itself. To prevent the ingress of moisture, the external face of the floor panels is covered with silicone cloth. When the floor is completely secure and level, the base plate for the wall panels is fixed around the perimeter of the top face, set in 15 millimeters from the edge to enable both skins of the wall panels to bear downwards on the floor. Once the base plate has been secured, we are ready to start installing the wall panels. The insulated wall panels include conduit for electric cabling, positioned according to the project design. The bottom of each wall panel has a recess that fits over the base plate, whilst the vertical edges fit together in a tongue and groove arrangement, providing excellent strength and air tightness. On the inside and outside, bottom edges are screwed to the base plate, and vertical edges are screwed so that adjacent panels are securely fixed to each other. On this particular building, the tops of the panels are solid, but for a multi-story project, they would have a tongue to allow the wall panels of the next story to easily slot on top. With the walls complete, we now fit joists for the roof, and then the electrician fits cable runs, leaving loops with intumescent protection, which in case of a fire can then be pulled through and reconnected. 11mm OSB is then fitted to the underside of the joists to support the roof insulation, and then after soffits have been formed, 18mm OSB is fitted on the top and sides of the roof, which is then felted. A 6mm fireproof board is fitted around all walls, followed by 12mm plasterboard to the wall and ceiling. For houses and flats, the internal face of the walls would have 12mm plasterboard, coated both sides with HWO1 intumescent coating, which brings this up to 1 hour fire protection, a 6mm fireboard screwed to the plasterboard, and a further 12.5mm layer of plasterboard. The external face would have a fire-rated board coated with HWO1 to give 90 minutes fire integrity, and then faced with the architect's desired design. But this must be to a minimum of 90 minutes fire integrity. Ceilings would have 2 layers of plasterboard. The internal walls of a home office would be finished to the requirements of the customer. The exterior of this building has a 5mm fire rates board finished with an attractive timber effect cement cladding planks.